Have you ever looked up at the night sky and wondered if we are truly alone in the universe? For centuries, that question has been a driving force behind our exploration of the cosmos. And sometimes, the most profound clues don't come from distant galaxies, but from visitors passing right through our own cosmic neighborhood. Today, we're diving into the fascinating story of a traveler from another star system, Comet 3IATLAS. Could this interstellar object hold the secrets to alien worlds? Before we get to 3IATLAS, let's set the stage. Our solar system is like a bubble, with the sun at its center and everything else orbiting it. For most of history, we believed everything we could see was part of this bubble. But in 2017, that all changed. Astronomers spotted an object named Oumuamua. Its trajectory was bizarre. It was moving too fast and at an angle that meant it couldn't have originated from within our system. It was our first confirmed interstellar visitor, a messenger from another star. Oumuamua was a game changer, proving that objects from other solar systems do travel through ours. Then, just a couple of years later, another one appeared to eye Borisov. Unlike the mysterious, cigar-shaped Oumuamua, Borisov looked and acted much more like the comets we're familiar with, complete with a tail of gas and dust. This was huge. It showed that comets' icy bodies, left over from the formation of planets, exist in other star systems and are similar to our own. It was like getting a postcard from an alien solar system, telling us their building blocks weren't so different from ours. This brings us to our main subject, 3IATLAS, discovered in late 2022 and confirmed as interstellar in 2023. It became only the third such object ever detected. The 3I in its name literally means the third interstellar object. Now, you might be thinking, okay, another space rock, what's the big deal? But every single interstellar visitor is an incredibly rare and precious opportunity. Think of it like this. It is a free sample delivered directly from another star's planetary system. We can't travel to other stars yet. The distances are just too vast. But these objects bring a piece of their home system to us. So, what makes 3IATLAS a potential treasure trove of clues? It all comes down to its composition. Comets are often called dirty snowballs. They're a mix of ice, rock, dust, and organic molecules, the very same carbon-based compounds that are the building blocks of life as we know it. By studying the light that reflects off 3IATLAS, a technique called spectroscopy, scientists can figure out exactly what it's made of. It's like a cosmic DNA test. When astronomers analyzed the light from 2I Borisov, they found water and other familiar molecules. This suggested that the chemistry in its home system was similar to ours. What will 3IATLAS reveal? Will it also contain water? Will it have the same organic molecules? Or will it surprise us with a chemical cocktail we've never seen before? If it contains complex organic molecules, it would add more weight to the idea that the ingredients for life are common throughout the galaxy. This is a central part of the theory of panspermia, idea that life, or at least its building blocks, can be seeded from one planet to another, carried on objects like comets. Imagine if 3IATLAS contained an unusual ratio of certain elements or isotopes. This could tell us about the specific conditions in the nebula where its parent star and planets formed. Was it hotter or colder than our own solar nebula? Did it have a different chemical makeup? Each detail helps us paint a more complete picture of the diversity of planetary systems out there. It's like being a geologist who suddenly gets a rock sample from another continent they've never been to. The single rock can reveal volumes about the geology of that entire region. One of the biggest questions is whether these comets could hint at the existence of planets themselves. Comets are typically thrown out of their home systems by the gravitational pull of large planets like Jupiter in our own solar system. The very fact that 3IATLAS was ejected from its system and sent on this journey strongly implies that it was flung out by a giant planet. So, its existence is indirect evidence for a planet orbiting another star. By studying its trajectory and speed, we can even start to model what kind of planetary system might have been responsible for kicking it out. Now, let us be clear. We're not talking about finding little green men hitching a ride on the comet. The clues we're looking for are much more fundamental, but no less profound. We're searching for the chemical prerequisites for life. Finding familiar organic compounds would be incredible. It would mean the basic ingredients for life might be scattered across the galaxy, like seeds in the wind, just waiting for the right conditions on a planet to take root. However, there's a challenge. 3IATLAS, like Oumuamua and Borisov before it, is just passing through. We have a limited window of time to study it before it disappears back into the void of interstellar space forever. That's why observatories around the world, including powerful instruments like the James Webb Space Telescope, race to gather as much data as possible whenever one of these visitors is spotted. Every photon of light collected is a precious piece of a puzzle, light years in the making. The future of this research is even more exciting. The European Space Agency is planning a mission called the Comet Interceptor. This spacecraft will be parked in space, waiting. The moment a new interstellar comet, like 3IATLAS, is detected on a path we can reach, the Comet Interceptor will be deployed to fly by it, getting up close and personal in a way we've never been able to before. Imagine directly sampling the gas and dust from another solar system. This would move us from remote analysis to direct evidence. So, could 3IATLAS contain clues about alien systems? Absolutely. It's a physical fragment from another star's family of planets, delivered right to our doorstep. Its chemical makeup tells us about the building blocks available there. Its very existence hints at the presence of planets in its home system. While it may not give us a definitive answer to "Are we alone?", each interstellar object we study adds a crucial piece to the puzzle, helping us understand our place in a galaxy that seems to be teeming with the potential for life. The cosmos is sending us messages, and we're finally learning how to read them. Thank you so much for joining me on this cosmic journey today. The universe is full of wonders, and it's a privilege to be able to explore them together. If you enjoyed this video and want to learn more about the mysteries of space, be sure to hit that like button and subscribe to the channel. Let me know in the comments what you think. Are these interstellar comets the key to finding life beyond Earth? Thanks again for watching, and I'll see you in the next one.